Python as a programming language. So Peter, I'm going to hand over to you now to share your screen, and you can go ahead from there.
Okay, hello, am I muted?
No, we can hear you.
Oh, okay. All right, hello everyone. Thank you, Ayodeji. My name is Peter, and I'm a developer. I live and work in Sweden. So without much ado, let's go straight down to business. Now, I understand that from experience, when we say programming, I did say that people need to understand how programming fits into the scheme of things. When we say we are programming, what are we trying to achieve? Yeah, so most of what we'll do today would be laying the groundwork for future lessons. There are certain basics that I think everyone should know before they begin programming. And so first of all, the first thing you need to know before programming or before saying you want to write any computer program, it's that your laptop, your computer, your mobile phone, your smart TV, everything is just a huge chunk of metal with electricity coursing to and fro, all the ICs and chips and stuff that are there. On its own, your computer cannot do anything, right? So if there was no software in this laptop wouldn't come on. It would just be a laptop. It would be an inanimate object capable of nothing. So, which means that for a computer to do something, it has to be instructed, right? So, which leads me to say that for every computer that you see, there is the part that represents the physical thing you can see, which we always refer to as hardware. And then there is a second part, which represents the instructions that enable users interact with that physical part. And that part is what we refer to as software, right? Now, the interesting thing about software and hardware is that, again, another caveat is that your computer does not know anything about the software it's running. As far as it is concerned, your hardware only cares about binary. What is binary? I am sure most of us will remember this. Whenever you see this is all your computer knows. 10110, whatever. So which means that every color, every mouse click, every keyboard stroke, whatsoever you do on a computer has to at some point be translated to binary before it can be executed. So what then does this mean? This means that no matter what you do on a computer, if it cannot end up as binary, then it is useless. Computer cannot do anything with it. And this includes your mobile phone, every electronic thing that you ever interact with, only ever cares about binary. So what this means, therefore, is that for every software, right, typically you could write programs in binary. Yes, you could. In the 80s and in the 70s, there were dudes that were writing computer programs in binary. Yes, they could write whole software packages, not as complicated as Microsoft Word or anything you know today. But then most of the early day software like Fortran, COBOL and stuff were written in binary, like ones and zeros. Someone sat down and typed only 2 characters all day long, 1 and 0. Very boring, right? Now, but then if that were to be, not everyone would be writing computer programs today. I mean, because it'd be really challenging to type 1 and 0 all day long and to understand what sequence of ones and zeros would produce specific actions and so on and so forth. So which means that there needed to be a higher level of writing instructions, right? So typically, there needed to be a way to write instructions in human readable form. And then this human readable language will be translated to binary, right? So this human readable form that I'm talking about now is what we refer to as programming languages, right? So basically, a programming language allows you to write computer instructions in human readable form, and then some other software on the computer help translate this human readable language to a stream of binary numbers, ones and zeros, because as far as we're concerned, all the computer is ever concerned with or worried about is ones and zeros. So which means that for every software, for everything that runs on your computer, someone wrote it, right? Because on its own, the computer cannot do anything. So which leads me to the next question. So if every programming language at some point in time has to end up as binary, why then do we have many programming languages, right? Good, that's pretty much the next thing. So basically, software is divided into 3 types or 4 types. I think 3, can't remember, not sure. So the first type of software you would see is system software. Now, when we say system software, we are talking about your operating system. Now, when we say operating system, your Android, when you boot up your phone, that software that boots up your phone and loads your contacts, messages and stuff, that's your operating system, right? Operating system. So basically, an operating system just enables the computer present an interface for you to interact with, right? Without the operating system, there pretty much is very little you can do, right? So, 2, another type of software you would typically see that belongs to the class of system software would be compilers or interpreters. Now, what are these, right? Now, I said earlier that when you write software in high-level languages, at some point in time, they have to be translated to binary. So, which means that there has to be another software somewhere that would take this thing you have written in human readable form and translate it to binary. Now, software that is responsible for that is what we refer to as a compiler or an interpreter. Now, we'll go into more detail about these guys soon, in a few minutes. Now, the next class of software we'll talk about will be application software. So when we say application software, we are talking about software that enables you do stuff, enables you accomplish tasks on a computer or a mobile phone or whatever, right? So on your smart TV, an application software would be maybe your YouTube or your Netflix software running on your smart TV. On your mobile phone, application software could be contacts, could be your messaging app, could be your WhatsApp, could be your Microsoft Word mobile app. Basically, any mobile app that you go to download, most mobile apps that you go to download from the Play Store, they belong to a category of software known as application software. All right. Now, aside from that, then you have utility software. Well, this is not generally, is not really, you really should be concerned about this, other than utility software is just software that you generally get to use to maintain your system, you know, clean your system, clean my Mac, disk defrag, disk manager, FSCK, you know, system level stuff, but they generally are focused on, you know, providing you with the functionality of being able to maintain your system, antiviruses, and so on and so forth. They belong here. So very important. I note that here. So now, so if we have system software, application software, and utility software, what then does, how then does programming languages, how does this affect programming languages, you know? So now, because your system software at some point in time needs to talk natively with the hardware, it means that whatever language that software is being written in has to, at some point, has to be compiled or translated to ones and zeros. So in other words, your computer must be able to boot up and immediately load the sequence of ones and zeros that it needs to power up and show you all these nice colors and software that you see on your system, right? So basically, whatever type of whatever language used in doing this has to be, once you type and you say deploy or compile or whatever it is, it has to immediately be translated to ones and zeros and shipped off to your computer storage media, where your computer would load it and run and so on and so forth, right? So that means that, first of all, software used in writing system software has to be able to immediately be translated to binary. That's very important. It should not require an intermediary to end up in ones and zeros. Now, but on the other hand, application software, they generally do not need to talk to hardware directly. Most application software, yeah. So what that means also is that whatever language was used in designing this application software does not need to be immediately translated to binary. No need to end up in binary immediately. Very important. Utility software, we'll skip that for now. So now, when we say that a language it must immediately be translated to binary, we generally refer to those languages that have this capability as compiled languages. We say that these languages are compiled, right? Now, just for academic sake or theory sake, for operating systems are generally written in C, C++, and more recently, Rust. I think one guy in Google also is trying to write a full Rust-based operating system. So programming languages are generally divided into those ones that you immediately ship to binary, compiled languages, and interpreted languages. Now, interpreted languages, yeah, you typically don't ship to binary. Sometimes, most times, they are shipped into a intermediate language format. So they are shipped into an intermediate language format, and then at the time when the application is running, that is when the actual translation begins to happen from this intermediate language to binary, right? Now, so important, very important, you should know this. Programming languages are generally compiled or interpreted. Now, what this means is because compiled languages would be faster. Why? Because when compiled, it ends up in ones and zeros, it is shipped up to the system. All the computer needs to do is to read those ones and zeros and execute. No, nothing special anymore. But for an interpreted language, so it has to be shifted to an intermediate language, and then just at the point where you run the computer, run the software, it then begins translation to ones and zeros. So which means that interpreted languages are generally slower. So how does this affect us as programmers? It means, therefore, that depending the choice of a language would depend on what you want to do, right? Now, typically these days, when we say programming, people generally talk about web applications or mobile applications or desktop applications, right? So I would, for now, avoid desktop applications. I would generally just focus on web applications and mobile applications, right? Now, a web application is an application that runs on a browser. So everything that runs on a browser is a web application, right? So if you have ever played a multiplayer game on a browser, that's a web application. Facebook is a web application. Whatever, TikTok, okay, no, TikTok is a mobile app. Your Gmail, basically once you fire up Chrome, Google Chrome or Safari or Internet Explorer or whatever it is, and you get to do stuff, you are basically using a web application. Mobile applications are generally all apps that run on your mobile phone, right? So now, in light of this, what is Python, Java, and the popular languages? What are they good at? How do they come into the sphere of web applications and mobile applications? The point is, so for web applications, you could typically use Java, you could use C#, you could use Python, you could use JavaScript, you could use Ruby, you could use Scala, you could use what else? What other language is popular? Okay, yeah, I think those are about the popular languages. No, people don't generally use Scala these days, but it's still there. I think there's a framework dedicated solely to people who want to use Scala. Then mobile applications. So if you want to write a mobile application, what language would you typically want to use or learn? So you basically would sit, if you are writing Android, okay, let's not go into that yet. You could typically use Java or Dart or JavaScript or Swift, and yeah, you could use C#, and I think that's about it. Yeah, every other thing is just combination of this. So basically, Java, C#, Python, JavaScript, Ruby, Scala. If you want to do a pretty web application like Facebook or Gmail or stuff, you typically would resort to any one of these languages. If you were to build a mobile application, you would typically resort to Java, Dart, JavaScript, Swift, or C#. I wouldn't want to go into the various operating systems and how these languages fit in and so on and so forth. So, but as far as we are concerned, we are only interested in Python, right? So first of all, what is Python? Python is, first and foremost, a scripting language. right? What does that mean? So these days, when we say scripting language, they generally refer to interpreted language. It's also an interpreted language, which means you can type, you don't need, you can type your code, you don't need to compile it or whatever. You just click run and your code runs immediately. So that's Python. Now it is functional. Python is functional. What does that mean? Now, for our practicals, I don't, for now, I wouldn't advise that, I wouldn't go into setting up PyCharm, setting up PyCharm or Visual Studio Code and, installing the Python interpreter on the various languages. I would like all of us to just head to rep this website, repl.it, right? And so it's something that allows you to quickly experiment with languages. You just type and you run, and you see the results immediately. And for this first class, this is what we'll be using, right? So are we all here? repl.it.
Okay, thank you. I think we should try and open our browser separately and go to that link so that it's faster for us. At least we are all with the computer system. So it's good we quickly go to that link, repl.it, so that we can follow what will be, the instructor will continue to do now. But very soon we are going to go on a short break because this 40-minute interval is going to come to an end very soon. But in case that happens, all you have to do is to, after a minute when you are logged off, just click back on the meeting link and then you'll be able to join us back. So we should try to do that as soon as possible while we also try to go to this site before you continue, Peter. Okay. Peter, you can go ahead.
Okay. All right. So if we're all here, so when we say that a language is functional, generally, I believe my predecessor must have given some background about this. I assume most of us are familiar with object-oriented programming. All right. So now so functional versus OOP. Okay, sorry. Versus OOP. Now the core difference is that, as far as these are concerned, functional, we generally think of functions as being the primary citizens, right? So as far as we're concerned, in a functional language, functions is first class. Once you have a function, you have a program you can run, right? But for an object-oriented programming language, you have to talk about objects. So for object-oriented programming languages, objects are first class. Objects are first class citizens. Right. So what does this mean? So it means that, let's say, for instance, that start coding. Let's see if I can switch to Java here. So I have two Java languages here. Now, this is the difference I'm trying to explain. Now in Python, you see that this is my Python interface, and this is my Java interface. You will see two fundamental things. My Python interface started with a blank screen, nothing. So it just expects me to start typing functions, right? And I can run. And then this is my result, right? I've just said print hello world to the screen and it printed. But if I were to do this in Java, I would need a class, a method, and the call to print, right? So, which tells us that interpreted languages or functional languages are generally more concise, right? That means that you basically have to type very little to get a lot done. Now, what is Python used for? Python is generally used for web applications. There have been attempts to try to get Python to be used in designing mobile apps, but it was not successful. So if you are learning Python, just have it at the back of your mind that you're never, ever, ever going to be able to use Python to design a mobile application. Python is also used for some system software. If you are in the Linux space, Linux is an operating system like Windows. Most of the Linux software you see are written in Python. I think this session is almost over. Okay. 1 more minute. Okay. So system software, you basically use Python for that. And then for machine learning, yes, most of your machine learning or AI algorithms today have APIs written in Python, right? And this also includes data science or data analytics. So if you are learning Python, it would be because you want to be able to do any of these three things: web applications, system software, or automation software. Automation software to automate things like every day, send a mail or stuff. You can use Python to do that. Machine learning, AI, data science, or analytics. Aside from these three, you could try, but then I wish you all the best in your endeavor if you try to use Python out